would like to welcome you to this webinar prepared by the Noise Controlled Building Materials Market Group here at Kinetics Noise Control. This market group specializes in isolated floors, ceilings, and walls. My name is David King, and I will be the presenter for this webinar. My role within the group here is the engineering coordinator. I work alongside of the Kinetics reps to provide technical information for the specific products involved for the projects. If at any point I use any terminology that you are unfamiliar with or would like a further explanation, please let me know in the chat. Here at Kinetics Noise Control, we do appreciate feedback on how we can better serve you and your project. If there's something that we touch on here, or another subject in general that you would like a deeper in-depth presentation on, please let us know. If for any reason you have missed a section of this presentation, please visit our website after the presentations have been completed. There you can find a live recorded version of this presentation for you to review and revisit. After the presentation, I will be available for any one-on-one sessions that specifically need to address your questions. To schedule your session, please email me at dking@kineticsnoise.com. In today's presentation, we'll be covering and discussing why weights are needed and important for your isolated project. The topics and sections that we are going to cover are calculations, selecting the right spring for the job, common situations involving isolated ceilings, as well as with isolated floors. When it comes to calculations, having all the information up front is important. Here are some typical items that your project coordinator will request: chandeliers and lights, their locations and weights, ductwork. If the ductwork is being supported by the isolated ceiling, it is important that we get the hang point attachment locations, along with the weight that each hang point will contribute to the ceiling. For the isolated floors, fitness equipment is a very common item. Most importantly, the multifunctional trainers and dumbbell weight racks, as there are various types and also varying in weights. If you have seen our submittals before, you should be familiar with this legend and information. The red circle in the middle represents the isolator location. The yellow highlight rectangle around represents the tributary area. This represents the surface of ceiling that this hanger will support, which is being represented by 8.4 square feet. The number highlighted in blue is the dead load value. This is the makeup of the ceiling times the square foot of the tributary area. Highlighted in purple are the miscellaneous loads. These are loads that occur in any one specific location versus throughout the entire isolated ceiling. Common examples are soffits, elevation changes, lights, and ductwork. The number highlighted in red is the sum of the dead load total along with the addition of the miscellaneous items. The 80.9 in this instance is referring to the amount of weight that will be imposed upon this spring. So how do we determine the tributary area of each spring's surface area? First, we look at the layout of the isolators. Here we have isolators with a 12-inch offset and a 48-inch on center spacing. Let's take a look at this isolator and its contributing neighbors. If we were to draw this line in between an equal distance of its neighbor to the left, and do that for the other three partners, we have developed the tributary area, which represents the equal spacing between itself and its neighbors. In this instance, we have a 48-inch by 48-inch tributary area, 24 inches to the top, 24 inches to the bottom, and left and right, which contributes to a 16 square foot trib area for this isolator. If we were to do the same for the two up top, we do not have isolators neighboring north and west. So for these instances, we will go to the perimeter of the isolated ceiling. How to know to select the right spring for the right job? As discussed earlier, the 80.9 is the weight that is being imposed upon the spring. So when it comes to the 80.9, we need to take a look at the spring rate and figure out the deflection. Here we have the equation of load on spring divided by spring rate equals deflection. So if I were to take the 80.9 and divide by, let's say, the 101.7 spring rate of the Muta 100 gray, we would develop a deflection of 0.79. If we were to take the 80.9 again and divide by the spring rate of 75, representing the 75 Muta black spring, we get a deflection of 1.07 inches. So in this instance, the 75-pound spring should be selected to support the 80.9 pounds. It is important to note the spring deflection family that you are viewing and selecting. The chart being shown is for 1-inch deflection isolators. This chart represents a 2-inch deflection isolator family. It is important to note that the spring rate shown in the right column is pounds to be imposed for 1-inch deflection. So if we take the top isolator, the LSM 250, 50 pounds of weight will produce 1-inch deflection. To achieve the 2-inch deflection, we need to impose 100 pounds of force. Let's talk about the isolated ceiling systems. So here we have a structural slab. We've attached our isolated spring ceiling hangers. And we've imposed, let's say, 2 layers of 5/8 inch chipboard ceiling. If we were to select the springs for the tributary areas, for instance, in this example, let's say that the 37 pounds is being imposed upon these springs. Now, the reason why we selected the 37-pound spring, because there was no lights or ductwork being imposed upon the ceiling during the design of the submittal drawing. But out in an installation in the field, a chandelier was to be installed, either being missed in the design phase or after the keys have been turned over to the owner and they would like to install chandelier. Let's say it weighs 25 pounds. Now, that 25 pounds is being added to the 37 pounds for a total of 62. Remembering that we selected a 37-pound spring to support the 37 pounds. Now that 37-pound spring is supporting the 62 pounds. The spring will not fail, but however, what we will witness is a dip in the isolated ceiling, for this spring is deflecting far more than anticipated during the design process. This could lead to cracking of the chipboard and other aesthetic issues that may need to be fixed and revisited. Going back to our original example, HVAC duct is a very common issue that we occur. In the instances where HVAC duct is being supported by the isolated ceiling, it is important for us to know where the attachment points are interacting with our ceiling. Is it in this location here? Or are the attachments down here being equally divided amongst these two isolated springs? Or is it here being imposed on the end springs and skipping the middle spring? And how much is that duct contributing? For every duct is different. Dual walled, insulated, what gauge of metal? We have no way of determining that, and we would prefer for the mechanical engineer or the mechanical contractor to provide as much information as possible to ensure a smooth installation and process. When it comes to the floors, our common offenders are fitness equipment. Here we have a dumbbell rack over on the left, on top of our LSM isolated spring floor system. Let's say this dumbbell rack weighs 1,200 pounds. And over on the right, we have an elliptical, treadmill, anything you would like that weighs a significantly less amount of, say, 200 pounds. During the design process, Kinetics project coordinator will select the appropriate springs to support the appropriate equipment. In this instance, we would have divided that weight of 1200 among those two springs. So say around a 600-pound spring plus supporting the weight of the concrete. Then over on the right, we would have added an additional 100 pounds to the weight of the concrete and floor to the other LSM springs on the right. Now, a very common occurrence that we are seeing is that owners like to be able to switch around the layout of the fitness equipment. As you can guess, this can cause an issue when you take a 200-pound piece of equipment and exchange it for the location of a 1,200-pound piece. So the two springs on the left that we're supposed to see an additional 600 pounds of weight are no longer seeing that. Therefore, the deflection is much less than anticipated. So you may have a high spot now in the floor. Same can be said for the isolators over on the right, who were only supposed to see 100 pounds of additional weight and are now seeing an incredible increase in weight of 600 additional pounds, thus causing the deflection to be much greater, potentially causing a low spot. How Kinetics has chosen to approach these situations is by zone loading. Normally, there are fitness equipments that require electricity, so the outlets are not going to change locations. So we know those machines that require electricity will be closely located to those outlets. So we designate a certain square foot to accommodate those common weights, so that when you change a 400-pound treadmill with a 300-pound elliptical, that weight is not drastically different. Thus, the springs will be able to accommodate that change. However, when it comes to weights like dumbbell racks, multifunctional trainers that can weigh over 1,000 pounds, it is important that the location of these pieces of equipment are coordinated and official before the design or the installation of the system. For switching the springs around to accommodate the change in equipment can be planned, but involves careful coordination. So the big takeaways that I would like for our viewers is to think of the spring isolation system as a scale. If the springs expect to see a certain amount of weight, they will deflect as selected. Hence, if we go back to the 37-pound example, that spring will deflect as anticipated. But if you add an unexpected weight of a chandelier or a ductwork, now you've tipped the scales and you're either over deflecting or under deflecting. Our project coordinators can only account for the weights of what has been provided. If you ever have a question of, does Kinetics need this? Please default to yes. We have no problem in sifting through additional information to ensure that your project is selected and designed accordingly. Most importantly, and a large hurdle that we face, is duct weight information. As mentioned before, duct weights can vary for the gauge of the metal, dual wall insulated, and other contributing factors. A duct plan is always appreciated, and if supported, the hang point locations and weights. And when it comes to the fitness floor zone loadings, the key items we would like to focus on are anything that is exceedingly heavy and stands out amongst the rest of the pieces of equipment. So if majority of the equipment weighs in a range of 200 to 400 pounds, and you have one item that weighs, let's say 800 to over 1,000 pounds, we would like to make sure that we coordinate the location of that to ensure that the springs are selected properly. As always, we find it important that you understand how to locate your local representative for if you have further questions or need to get started on a project that might be up and coming in your area. On our website, if you go to the contact button in the upper right and select local representative, you'll be taken to this page here. Please enter the location of your project. Under the select noise control types, Select floors, ceilings, and partitions. Create quiet. Then select Find Rep. A pin should drop at the location that you've provided, and along with a pop-up window showing the company name, website, points of contact, phone number, and email of your local representative. Some may only have one name listed, while others may have 3 or 4. As always, if you have any questions on the webinar, we are here to help. You can reach us or any one of our team members at the following phone number with the extension of 752 or by emailing the Architectural NCBM group at arcsales@kineticsnoise.com. I do appreciate your time, and I look forward to you at our next upcoming webinars as they are posted. Thank you all, and have a great afternoon.